everybody, welcome back. Today we're jumping back into our networking journey and we're answering the question, why have more than one network? The short answer is that if you've got anything beyond a normal home or a real small office, then you almost certainly have either technical or policy reasons to control how many devices are in a single broadcast domain and which of those broadcast domains can talk to each other. Want to know more? Stick around to find out. Let's get into it. When you've got a handful of devices at your house, you're almost certainly fine with a single network for all of the devices there, probably starting with something like 192.168.1. something or another, and all probably behind some kind of home router like this, where you've got the internet out on the other side plugged into the WAN port, and everything else either plugged into one of your LAN ports or the Wi-Fi, but very likely all on that same network, and that's fine. But when you get into an office environment, or when things get more complicated in any kind of office environment for sure, gosh, you're going to have maybe desk phones, if that's a thing in your office. The servers are going to have storage networks. There's going to be maybe guest networks as well. And almost certainly, you're going to want to be able to decide and control for either policy or technical reasons how many devices are in each of those broadcast domains and who has access to those different ones. And you're almost certainly going to need multiple networks to do that. Let's get to drawing. So I think, Tiny Brian. Okay. First thing, I want to start with the flat network. A flat network is the sort of common way of referring to having that single network, that single broadcast domain. And back when I was helping folks out with this, very often it would be that had been working great for them for a while, but maybe things are starting to feel a little constricted and they want to switch over to having multiple networks. So let's do it here. What we've got in this case is a firewall that's going to be acting potentially as our gateway as well for our clients. Now, drawing a castle with little crenellations is a pretty common way of drawing a firewall, but it's not like the official way or anything, but it makes me happy, so I'm doing that. So that's going to be our firewall and router and everything. And on the other side of that is going to be the internet, right? Whatever that looks like. Boop. And then we're going to have, presumably in this case, some layer 2 switch hooked up to our firewall. And then as things grow, you end up with more and more layer 2 switches connected off of that. Let's just cable things up here. Boop, 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 and connect to our probably acting as default gateway for all those clients in this case. It's hooked up to the internet as well or whatever. And on the that firewall or whatever, yeah, they've got some public IP address on the outside. 100% not this, but let's just lie and say it's 1.1.1.1. That's public space. It's not your IP address and it's not mine. That's Cloudflare's DNS server. We're going to lie and pretend that's our public IP. And then on the inside, let's say that the address is 10.0.0.1/24. Okay, and then all of the machines inside of there would all have addresses in that range. We're gonna do subnetting pretty soon, but not today. Not today. This /24 though would mean that the first 3 octets or 3 dotted numbers have to match up. So all the addresses here would be 10.0.0. something. Sure. And so here, I'm not going to put them all in here, but let's say that first computer anyway has an address of 10.0.0.10 and a gateway of 10.0.0.1. And all the other computers get their address as well, 11, 12, 13, 14, on through whatever. Again, for a small office or for my house, your house or whatever, this is perfectly fine. But one of the things that we're going to run into that's going to kind of like become a limiting factor there is if I want to have more and more computers, I might run out of addresses with this scheme. I did 10.0.0/24 network, and that's only going to give me 254 usable IPv4 addresses. It's not much. I can certainly give it a bigger network, but that can run into some different challenges. Oh my goodness here. So what kind of problems would you run into if you were in this situation? If you've got this flat network and you're trying to decide, do I need more? Well, usually it's going to be the number of devices in your broadcast domain. Here I did this /24. So the first 3 octets have to match up. It could have been a much bigger network. Maybe I have more addresses within the network, and so less of the address has to match up for everybody. Again, we'll talk about that more for subnetting. And so maybe I went real big, real big. I do not recommend this, but let's say it was a /16. Whoa, okay. The first 2 octets are the only thing that have to match up now. And so now everybody's 10.0 and 10.0.0 through 10.0.255.255 are all on the same network. Okay, cool, now I'm not gonna run out of IPs, but you're gonna start seeing it where your network is slowing down because all of these clients out there, anytime they send any kind of these broadcast or unregistered unicast or multicast messages that don't just go to one destination, it gets flooded to everybody. And if it's, about 200-ish, 250-ish devices on a broadcast domain, no big deal. 1,000, pushing things a little bit depending on what you're doing, but maybe, what is that, like 65,000 if it's a /16? That's not okay. That's almost certainly going to give you trouble, so that you've got more and more of these shouts that are basically constantly hitting everybody else's NIC, and they throw it away almost certainly because it's not to them, but they got to check to see if it's for them first. And so that's one of the challenges you're going to have. Too many broadcasts, unregistered unicast, multicast, getting flooded all over the place. And you want to split that up so that, right, like it'd be like almost like having a class in a giant amphitheater. Heck, you do that in university, right? A class in like a basketball arena. Well, any little conversations, you're all hearing each other and it's just too much. You're constantly having to ignore too much and having trouble focusing on the thing you care about. Smaller classrooms mean you've got less background chatter to deal with, to ignore. You can focus on what you want. And again, smaller broadcast domains that map to then smaller networks would be a thing that would help you out there. Second thing that you would want potentially that might be a pain point is to be able to say, look, I've got some clients over here and some clients over there, and I want to be able to define who can talk to who. If I split things up into multiple networks, say everybody over here in these 2 switches, they're in the 10.0.0.0 network, and everybody over here is in the 10.0.1.0 network. And they have their different default gateways. Yeah, we got the different limited broadcast domains now, and they have to go through the router to talk to each other. But now I could also then have something like an ACL, not officially a thing we're talking on here, just touching lightly, an access control list that can be used to limit who can talk to who. And that is a lot easier if you can say, this network can talk to that network, or this network can't talk to that network. Being able to define who is a source and who is a destination by a network address that you've already mapped out can make that a lot easier. Firewalls, similar. Maybe maybe you're doing micro-segmentation with firewalling to be able to say, look, I want to be able to say that these hosts in this network and those hosts on that network can or can't talk to each other. Being able to split them up into those different networks can help make those policy decisions, enforce those policy decisions. Yes, and then there might be technical decisions, things like voice over IP. If it's software voice over IP, an application running on your computer, probably, well, definitely it's not going to be in its own network. But if you have a classic phone, a desk phone, almost certainly you're going to be putting that in its own VLAN network and then being able to prioritize that traffic, potentially depending on the IP address, the network that they're in, to be able to prioritize that as well. Depending on what you're doing, if you, again, we'll get into quality of service much later. Being able to identify that based on network can be really helpful. Okay, so these are some of the pain points you might have that might push you towards having additional networks. One of the other classic reasons is if you're trying to, in your office, have a server network and a user network and have these things be separate. So coming back again here to our thing we started out with, let's not do a /16. I'm going to back up here a little. Maybe that 10.0.0.1 is just an address that's on like this one interface. Ooh, we'll deal with that a little bit more down the way. But I'm going to change things up, get rid of our IPs here. And let's see if I can get a little more space. Heck, I'll move half of these somewhere else. Y'all can be up there. Hello. All right, just cleaning up here. Basically just giving ourselves a little more space to work. Something like that. Okay, and so maybe between our firewall and this thing that we're going to assume now is a layer 3 switch that's acting as like our core router, maybe there's a little tiny network that goes between it and the firewall. The 10.0.0/30. Oh my goodness. Again, we're not really getting a subnetting here, but a /30 has 2 usable addresses in it. That would be 10.0.0.1 and 10.0.0.2. And so that would be a network basically that lives on that cable. All right, and then maybe these are additional VLANs that I've got on here. And so maybe I've got, pick slightly different colors. Everybody down here on that bottom left, maybe they're all part of VLAN 10. And they've got an IP, all IP addresses in 10.0.10.0/24. Yeah, and so on this interface, or on VLAN 10 on that layer 3 switch, I've got an address of 10.0.10.1/24. Okay, and because we're just going simple here, let's say that these are all VLAN 10 because we're just having these users on one network and our servers on the other. And so let's say everybody over here, these are our servers. What kind of servers? Man, it depends on what you're doing, right? In a lot of cases today, this might just be infrastructure in the cloud. And so, you don't need to worry about that. That's on somebody else's data center and you're renting access to it. Yay! But if you do have an environment that needs to run on your own equipment, maybe this is application servers where you fill out your TPS reports on some web interface on some server. Maybe this is media streaming servers, depending on what you're doing. You're in back in that arena or whatever, those TVs that are all over the place walking around, as you're walking around saying, Sunday, big truck rally. Well, maybe there's a media server somewhere that's streaming out basically video or effectively a PowerPoint as video to all those TVs with receivers on them. You stick that on its own network, right? Maybe there's servers that are crunching some numbers for you and they've got back-end infrastructure, the storage and whatnot for them. Right, and you want to have these separate. Whatever makes sense for you. Classically here, it might be big enough where you've got your users and your servers, and those servers over there, you'd want to have at least in some other network. And so now, yeah, maybe they are all over there in, say, VLAN 20. And VLAN 20 is the 10.0.20.0/24 network. And they've all got their addresses over there, 10.0.20. Whatever. 10/24 and a gateway of 10.0.20.1. Right, and all addresses out in that range over there. Clients again back are over here. 10.0.10. Whatever, maybe 10/24 and a gateway 10.0.10.1. Right. And those gateways being VLANs in this case on whatever this layer 3 switch is, that's your core device. And now, again, we can limit things so that with those ACLs that we talked briefly about before, access control lists, or firewall policies, or whatever else, depending on if you were going through that firewall that would slow things down, to be able to control what type of traffic can make it over there. Yes, HTTPS, no SSH or Telnet or remote desktop. Right, because anybody who needs access to that should be able to directly be on that network or have some other means, but not do it from back at their desk. Yeah, and so again, reasons that you might want to split things up to control access to what's happening over there and what types of traffic can get back and forth between here and there is a lot easier if we can split it up into different sets of addresses that we can define then and say, yes, permissions for this to talk to that or not, and control what goes over there. It's a lot easier to do when it's in different networks. Okay, and then you get into specialized networks. In the client side, the campus side of things, that's going to be something I hinted at before, like a desk phone would be the classic thing, right? Where your desk phone is plugged directly into the switch, but your computer is not. That there's some little phone. As I slowly draw a phone. totally worth the wait. And the idea likely would be that the phone is plugged into the switch and your computer is plugged into the phone. And there's basically a little tiny switch in the phone. And you would have a tagged VLAN, a trunk coming down from the switch. And the tagged VLAN goes to the desk phone and the untagged VLAN gets passed through to your computer. And in this way, that phone has its own broadcast domain, its own network. And the reason you'd have that is because that's going to help you control the broadcast so that those tiny little computers that are the phones don't have to deal with a bunch of extra messages they got to discard that they don't need. It's also going to make things easier as far as them being able to pull an IP address through DHCP that is going to let them get to a server that passes down information that they might be looking for programming them so that they get the right info when they boot up, or for being able to prioritize the traffic based on it being in that different network. That's a classic example for why you might want a specialized network in a campus environment. Nowadays, even more, it might be for guest wireless. Yeah, whether or not you got physical desk phones, there's a decent chance there's guest wireless. And again, you would want to be able to have that in its own network so that you're then almost certainly firewall between that and the rest of the network could control, yes, you have access to the internet and nothing else, and also not each other. But it's easier to define that when you can say, look, I know you're all in this set of IP addresses, and so here's the rules that apply to you. Awesome. And in the data center, all of those servers over there, as you get bigger and bigger, are likely to not have their storage be all internal. In fact, hang on. Okay. So for a given server, there we go, server A, likely it is connected up to whatever switch that's got access to the rest of the network and eventually makes it back to your computer out there. Now, what's between here and there? Man, I don't know, a lot of network potentially. I'm just going to draw that as cloud. I don't know, it's a mystery. And so, sure, there's some NIC on the back of that server that's hooked up to whatever the switch is that's in the top of rack that goes to something between here and there and eventually makes it to your computer. Why? Well, because this, again, is that web server that you own, your company owns, where you fill out your TPS reports. Maybe it's your email server, a little less likely today. More and more that's moving into the cloud infrastructure. Active Directory server, file server, maybe directly even. Whatever. This is something you need to get your job done. And so there's some NIC on the back of there that when you go to do a DNS lookup, Active Directory, check credentials, whatever, you can get to that computer. And so can all the other dozens or thousands or tens of thousands of people that need to. Love it. But it's pretty likely that that server, like we said before, isn't just using its own internal hard drives. That when you go to check your email or whatever, there's actually some other device, whether it's called a SAN or a NAS, something, there is a box of hard drives with almost certainly specialized software on it, though it could be specialized software configured on like a Linux server or something, but whatever. And that is also connected up to the network. And the storage, you go to check your email or whatever, sure, you send the email and it goes through the server, but the actual files are stored on this other storage device out there. And how do we get to that? Well, maybe there's completely dedicated switches. That'd be great. If not, though, and pretty often not, well, hopefully there's at least dedicated NIC. Yeah, hopefully you've got, heck, I'll do a slightly different color here. I'll do light brown. Hopefully you've got at least a second NIC on that server for getting access to the storage. Why? Well, because it is a real bad idea to make that server compete using the same NIC, the same port on that switch, compete for bandwidth for serving out its purpose to the users and getting access to its own hard drive. There's no winner when you're competing for bandwidth on that server between doing its job of serving users and getting to its hard drives. Because if you put too much bandwidth or through prioritization into getting access to its own hard drive, well then users have a bad experience. If you put too much prioritization into the users getting access to it, then okay, well now suddenly it gets like read and write errors and maybe corrupted files. That's worse, maybe even. right? And so by having two different NICs on there at least, well, cool. One of them is dedicated for getting access to the storage and the other for using the users getting to it. Okay, well, cool. How do you tell it which of those NICs to use then? Well, almost certainly different networks. If it was just all on the same switch here, okay, cool. My light brown one here is all on, say, VLAN 101. Doesn't matter. And that's my storage network. And my blue one is on VLAN, doesn't matter, 201. And that's my server, user access network, whatever we call that. But the thing is, these names that we're using to describe these, that's just like us talking about them. The server's got to know what to do with these. And so to make that work, yeah, these are different broadcast domains, different VLANs, and we might talk about them different, but they're going to be different networks. There's going to be some IP address on the NIC with this imaginary brown cable here, and a different IP address in a different network on the one with the imaginary blue cable. And so maybe down here, it's 10.0.101.10/24. And that storage box probably has multiple IPs and multiple NICs, but we'll just say .100 is its address. All right. And let's say that my NIC with the blue cable plugged into it has an IP address of 10.10.10.10. Sure, why not? /24. And there's maybe a default gateway of 10.10.10.1. And that is on, VLAN, I guess 201 on this layer 3 switch or something like that. Okay, great. And so your computer out here is, I don't know, 10.0.0.100. So completely different. /24. All right. When that server says, hey, I'm trying to get to my SAN, how do I get to it? Well, what's its address? 10.0.101.100. How do I get there? Oh, well, I got two NICs. One is 10.0.101.10/24. The other is 10.10.10.10/24. And it's going to say, oh, I'm trying to talk to someone that's already on my same network. Yeah, no problem. I'll just send the message out that NIC. And so it does. And so all the storage traffic goes out of that NIC. When it's trying to talk to you over there at 10.0.0.100, it's going to say, well, I don't have a NIC in 10.0.0.100. Oh, but my default gateway is where I send stuff that I don't know where to go to. And that's at 10.10.10.1. Oh, how do I get there? Oh, out of this NIC. And so it goes out of that NIC. Yeah, and now they're not forced to share bandwidth on either one of those ports through the cunning use of having more than one network. Yes, okay. And so this is the big idea of what I wanted to talk about today. Because we're about to get into routing and subnetting. And to my mind, a lot of what gets lost in there is, in the, how to do it is why. Right? Why have another network? Why split things up? And it's going to come down to this, like we said before, policy or technical reasons. Technical, I need to have two different networks here to send traffic out of the correct NIC. Policy, I want to be able to split things out to, set up ACLs, firewall rules or whatever, and be able to define who has access to what across these networks. But I need to have you all lined up in nice, neat sets of addresses. Or maybe even kind of a combination as you grow, being able to decide, this is my range of addresses for my Austin office, for my Dallas office, a completely different range of addresses for my New Zealand offices. When we get into subnetting, we'll make even more sense of that. All right, everybody, you rock. Thanks for being here. This continues to be a blast. Do me a favor. I don't know if you're wondering a little bit more about this, or if you've got a story to tell about having that challenge of bringing up an additional network, maybe even re-IPing if you didn't have a plan to begin with for splitting up into multiple networks, let me know down there. No secrets, don't want to share any secrets, but yeah, share what you can. Otherwise, let me know what you want to talk about next. If something's, burning question, maybe I can bump it up in the list. If you like what you're seeing, like it. If you want more, subscribe. We'll see you next time. All right, settle down. Hey, I said settle down. Okay, I'm just gonna have to separate y'all, aren't I? Okay, hang on. You over there, you over there. Uh-huh. Okay, that's better, but keep it quieter, and if you have any messages to pass along, send them through me.
Me Grimlock, want play with party cannon. Tell stupid Decepticons me ready.